On this video, I'm going to read through the questions which we're going to see for mid-topic assessment, give a few little pointers here and there. So it's worthwhile having your homework out in front of you and pausing the video at various points as we go through it. This question is about metal oxides. When sodium is heated in oxygen, sodium oxide is produced. So part A, balance the equation for the reaction. So we have the equation something Na plus O2 forms 2 lots of Na2O. Now, just to remind you, these small subscript numbers, they multiply everything to their left. These big numbers here multiply everything in front of it. And for this question, you need to tally up the number of sodiums on this side, on our product side, to work out how many sodiums we need here on our reactant side. For question B here, what is an oxidation reaction, or in this case, why is this an oxidation reaction? We need to think about our definitions of oxidation. So we have our oil rig picture up here to give us a reminder about what that is in terms of electrons, but you can also think of that in terms of gaining oxygen. Question 1c, sodium oxide is added to water and shaken. Universal indicator is added. The pH of the solution is 14. What is the colour of the universal indicator? So we can use our pH scale here to select the right one. Question 1d, aluminium oxide reacts with hydrochloric acid to produce a salt. What is the name of the salt produced? Tick one box. So only picking one option here. Is it aluminium chloride, aluminium nitrate, aluminium sulfate, or aluminium sulfide? Now, the exam board expects you to know the formulae and the name of three acids, hydrochloric, sulfuric and nitric acid, and know what salts they've made. So use the table to help you with that one. So question 1e and the subsequent ones are going to be a bit more detailed in using this data in this table. A student investigates the solubility, so how easily something dissolves, of 4 metal oxides and 4 non-metal oxides in water. The student tests the pH of the solutions formed. The table shows the student's results. So we've got the type of oxide, whether it's metal or non-metal oxide. We've got the oxide, and we've got their particular names, and we have the solubility in water there and the pH of the solution. So sodium oxide is soluble, that means it dissolves in water and has a pH of 14. Calcium oxide also soluble, pH of 10. Magnesium oxide is slightly soluble, so it dissolves a little, pH of 9. Zinc oxide is insoluble, it does not dissolve, and no solution is formed to test the pH of. Our non-metals, we've got carbon dioxide, which is soluble, and a pH of 5. Sulfur dioxide, also soluble, and a pH of 2. Phosphorus oxide is soluble with a pH of 1. Silicon dioxide, insoluble, does not dissolve, no solution form. The student makes 2 conclusions. Conclusion 1, all metal oxides produce alkaline solutions. Conclusion 2, all non-metal oxides produce acidic solutions. So for part E, we're asked to explain why the student's conclusions are only partly correct and use the information in the table. So they want you to quote some data here. So you can say what they got right and then say what they got wrong and give the examples of what they got wrong too. So for 1F, give an improved conclusion for the metal oxides. This is worth 2 marks, and they want us to use a table. Now the bit of table that's relevant is this metal oxide section here, these 4 rows. So use that to make an improved conclusion. So state what those results show. Question 2. A student investigated the reactivity of 3 different metals. This is the method used. 1. Place 1 gram of metal powder in a test tube. 2. Add 10 centimetre cubed of metal sulfate. 3. Wait 1 minute and observe. 4. Repeat using the other metals and metal sulfates. The student placed a tick in the table below if there was a reaction and a cross if there was no reaction. So we can see the table there. So if there's a tick there, that means the metal is more reactive than the metal in the sulfate. Part A asks, what is the dependent variable in this investigation? Tick one box. So we need to remember what our variables are. Independent is what you change, dependent is what you observe or measure, and control is what you're keeping the same. So in this question, what is the dependent variable in this investigation? Time taken, type of metal, volume of metal sulfate, whether there was a reaction or not. What are the students observing? Tick the right box. So for 2B, we're using the same data and they want us to give one observation the student could make that shows there is a reaction between zinc and copper sulfate. So what might they see, that's the observation, what might they observe, what might they see that show the reaction has taken place? Question 2C, the student used measuring instruments to measure some of the variables. Draw one line from each variable to the measuring instrument used to measure the variable. So it's asking you to say, what would you use to measure the mass of a metal powder? What would you use to measure the volume of a metal sulfate? And the choice of equipment is balance, measuring cylinder, ruler, burette, thermometer, test tube. And I should only see two lines, so one line going from the metal powder to wherever it needs to go, one line from the volume of metal sulfate to the appropriate piece of equipment. Then, for part D, use the results shown in the table above to place zinc, copper and magnesium in order of reactivity. So most reactive at the top, least reactive at the bottom. So you're thinking the more reactive elements will displace more of the other ones. For part E, suggest one reason why students should not use sodium in this investigation. So why would it be a bad idea to add sodium to an acid? What do we think might happen? Then, question 2F, which metal is found in the earth as the metal itself? Tick one box, calcium, gold, lithium or potassium. So a metal that is found in the earth by itself will be a really unreactive metal. Which one out of those four is really unreactive? Then for G, iron is found in the earth as iron oxide, Fe2O3. Iron oxide is reduced to produce iron. Balance the equation for the reaction. So you can see here where they've put these lines, that is where we are going to put our numbers. We can't put them anywhere else but those four places. And the best way to approach these balancing equations is to tally up the atoms on each side and then work from there. Part H, name the element used to reduce iron oxide. So this is the experiment that we did in class with the matchsticks. So what element, and you can look at the equation to help you, is used to reduce the iron oxide? Then we're asked to say, what is meant by reduction? We were asked earlier what was oxidation. Now we're being asked about reduction. So is it the gain of iron, the gain of oxygen, the loss of iron, the loss of oxygen? We've got our oil rig to remember here, and we met oxidation earlier, which was the gain of oxygen. So what might reduction be? Question 3. Another experiment here in a lot of detail to go through. A student investigated the reactivity of different metals. The student used the apparatus shown in the figure below. So we have a thermometer in a beaker which has got dilute hydrochloric acid and a metal powder at the bottom. The student used 4 different metals. The student measured the temperature rise, so that's the change from what it started at and what it ended up as, for each metal 3 times, so they repeated their experiment. The students' results are shown in the table below. So you can see we've got a column with our metals in, then we've got our temperature being recorded here, 1, 2, 3 times, and then they've taken a mean temperature rise in degrees Celsius, so they've averaged the results here. So the question asks us to give two variables that the student should control or keep the same so that the investigation is a fair test. So what do you think they should be keeping the same each time? Part B, one of the results for magnesium is anomalous. Which result is anomalous? Suggest one reason why this anomalous result was obtained. So an anomaly or anomalous result is an outlier. So looking at these 3 data points here, which one do you think stands out as being a bit of an outlier, not matching the pattern? And then I want you to think, well, why is it that number is so different? Was there any, well, I can't make suggestions without telling you the answer, but have a think. What might have caused that number to be so much different to the other ones? Then for part C, they want us to calculate the mean temperature rise for calcium. So they want us to kind of work out what should go in this grey box here. So there's not any anomalies in there. So you're going to calculate a mean by adding up these 3 data points and dividing by the number of data points there are. So add up these 3 numbers and divide by 3 to get your value. Always show your method on these calculations so you can get any method marks too. D. The temperature rose when the metals were added to sulfuric acid. Give one other observation that might be made when the metal was added to sulfuric acid. How would this observation be different for the different metals? So what else would you see? We've got metal plus acid can make salt plus hydrogen. What might we see and how might there be a difference? Then finally, question E, aluminium is more reactive than iron and zinc, but less reactive than calcium and magnesium. Predict the temperature rise when aluminium is reactive with dilute hydrochloric acid. So use those other values in the table, kind of look where it might be in that order. What kind of number will it be? They will accept a range of answers here, so don't fret too much.